Hello. The question I'm asking in this video is, can hurricanes trigger earthquakes? So let's consider some of the recent evidence or observations where there seems to be an earthquake simultaneous with a hurricane moving through a basin. So consider Category 5 Hurricane Maria. As it was going through the Caribbean, there was an earthquake in Mexico City, 7.1 earthquake. The week previously, as Category 5 Hurricane Irma was moving through the Caribbean basin, there was an earthquake just off Mexico. With Hurricane Maria, that 7.1 earthquake in Mexico seemed to trigger a volcanic eruption. Okay, so can we connect the vibrations that are created in the earth by large storm, for example, a large meteorological event like a hurricane, with vibrations in the Earth's crust, which is enough to trigger an earthquake, if the earthquake was primed to go, and also trigger a volcano if the volcano was primed to go. Hurricane Harvey, a week or so before Irma, deposited so much water over Texas, the Houston area, that weight of that water depressed the the top of the earth. It depressed it about an inch, 2 centimeters. A number of years ago, when Hurricane Sandy was moving off the eastern coast of the U.S., there were seismic sensors went off across the U.S., and there was an earthquake off Vancouver. As Hurricane Sandy turned left, there was a second earthquake as the seismic sensors lit up across North America again. And then as Sandy came ashore, this was in 2012, there was yet a third earthquake off Canada, the Queen Charlotte Islands region. In 2011, there was an earthquake on the east coast of the US. In fact, Washington Monument was damaged, etc. And then a few days later, Hurricane Irene came ashore, and there were lots of aftershocks from the earthquake that had just happened. Instead of exponentially tapering off like they would normally do, there was a steady, constant, and in fact even a rise of aftershocks that can be attributed to or were simultaneous with Hurricane Irene. So the big question is can these large storms, these large hurricanes, can they set up enough vibrations in the earth to trigger earthquakes, even volcanoes? And it appears just from the evidence that all these events are too much of a coincidence for this to just be a coincidental thing. So I'm going to argue in this video and in the next one that that basically there's an interconnection between the meteorological events and the geological events. So the answer, essentially, the short answer is yes. It appears that hurricanes are actually triggering some of these other events. So I'm Paul Beckwith. This is my website. I've done hundreds of videos to educate you, the public, on abrupt climate change. I usually teach at Carleton University, usually at Ottawa University, and I taught at Carleton last term, taught 8 or so courses, but I'm not teaching this term. So please consider a donation to my PayPal to allow me to produce lots of these videos and also make suggestions as to what videos you would like to see. Okay, so let's get into these connections. So this is a very interesting book, which I highly recommend if you want to learn more. It's called Waking the Giant. It's by Bill McGuire. He talks about how a change in climate can trigger earthquakes, tsunamis, and volcanoes. Okay, So, 20,000 years ago, we had ice covering lots of North America. Temperatures were 6 degrees lower, ice sheets were kilometers thick over much of Europe and North America. Sea levels were 130 meters lower. Since then, as the ice was melting, that ice has a huge amount of weight. The density of the ice is 0.9 grams per cubic centimeter. The bedrock underneath is about 2.7 grams per cubic centimeter, which is lighter than the basaltic ocean crust at 3 grams per square centimeter. So the continents ride up over the ocean basalt, and the ice on top of the bedrock depresses it. It pushes down. It's about a third the density, so 3 kilometers of ice would conceivably push the surface of the Earth down a kilometer. So as all that ice melts, the Earth comes up. There's lots of stresses. That could trigger earthquakes because of the crustal isostatic rebound, the bouncing back up. Tsunamis, it can trigger submarine landslides, for example, which can then trigger tsunamis, or earthquakes which trigger tsunamis, etc. So this book looks at all of the details of that. Now, let's go back to 2012. This is an article that I wrote that was in Arctic News. So the question is did Sandy trigger major earthquakes off Vancouver? So Sam Carana wrote, I did a blog about this, and Sam Carana wrote about the blog and also talked about what I was saying in terms of the, what was happening. So, okay, so basically what happened is, this is the wind speed of Sandy. Now, Sandy was a huge storm. Okay, this is as it's approaching the U.S. coast on October 28, 2012. So there's Sandy about to come ashore off New York. Okay, and here's some images. There was a video that was posted by somebody who was monitoring all these little seismometers on the U.S. And what these things light up red when there's motion. So this is the amplitude. So as Sandy was moving up the coast of the U.S., there was a magnitude 7.7 earthquake up here off Canada. Okay, 7.7 hit the coast off Vancouver on October 28, 2012 at about 2 p.m. Eastern Daylight, or 2 o'clock Eastern Daylight Time. It was later upgraded to 7.8, and the time was slightly later, UTC, 4 minutes after. Okay, so this is the seismic sensors on the, and this is different motions, vertical ground motion, north-south ground motion, east-west ground motion from these sensors. At that time, the earthquake was triggered. Now, the same day, later that day at 1700 Eastern Daylight Time, Sandy started to turn left, and the sensors all lit up again like this. They'd gone off quiet. They were like this, and they go quiet, and they came up, and they're not as. And then they got intensely lit up again as Sandy turned left, and there was an earthquake off here, a 6.3 earthquake. Hit very close to where the first one, the 7.7, had occurred, and then. Later on, the next day, Sandy did her turn left and was coming ashore. The sensors all lit up as following, and a 6.2 earthquake happened, followed here. Now, this shows the time of those 3 earthquakes, the 7.8, 6.3, and 6.2. This is where they were occurring right here. Okay, this is part of the North American plate. There were 90 further earthquakes in the area with a magnitude of at least 4 within days. Okay, now this is what I wrote about whether Sandy was the trigger back in 2012. Sandy was a massive storm packing a huge amount of energy equivalent of 5 Hiroshima-sized nuclear bombs, according to Jeff Masters' Wonderground blog. When she approached, she was detected on the seismic stations. Her large size, tropical storm winds were within a 900-mile diameter. So this is a huge storm, sucked up huge amounts of water, low pressure center. And it adds tremendous stresses on the Earth's crust and pushes it downward. All that extra weight that's water's pulled towards Sandy, that extra weight on the Earth's crust, it can deflect the Earth's crust and set off these seismic stations. So there was an animation of her progress, and it showed the ground stresses between October 14th and November 1st. Okay, so she's moving northward, and the 7.8 magnitude earthquake occurred. She continued northward, and just before her unusual left turn, which was because of the jet stream configuration, she couldn't move north, she couldn't move east. There was another maximum of seismic activity and a 6.3 magnitude earthquake or aftershock. Then Sandy turned left and crossed the coastline just south of New York City, and there was another large aftershock, 6.2 magnitude. And this aftershock again coincided with the seismic sensors all lighting up red. Coincidence? I think not. Stress on one side of a continental plate, so the North American plate can deflect the plate downward locally and cause it to bow up and down or down afar, on the other side of the plate at the west coast. So the shock waves can just go through the Earth. The precise coincidence of the timing for the main quake and two aftershocks with peaks of seismic activity on the East Coast seem to match too closely to be a coincidence. More study is required. Okay, so let's have a look. Let's go on here. Okay, so these are the plates here. Okay, so Sandy comes ashore, 3 earthquakes over here as the seismic sensors light up. Now, with Hurricane Maria coming across here, did it set up vibrations in the plate and trigger the earthquake in Mexico? And that earthquake in Mexico seemed to trigger a volcano also. Hurricane Irma, a week earlier, came across another earthquake just off Mexico. And I've also mentioned the Hurricane Irene, which started shaking the seismic sensors after an earthquake on the East Coast in 2011. Okay, so are we seeing, is this actually, it seems more than a coincidence. It seems like there's a connection here. Okay, so we know that the Earth is connected. So the question is, can one earthquake somewhere trigger another earthquake somewhere else? So the point is if the Earth stresses build up in the Earth. There's movement without sliding. Stresses build up in the Earth. Stresses are the forces. That creates strain. The Earth starts deforming. And then if it suddenly gives way, then it creates a quake because there's an elastic rebounding effect. So there was a Costa Rica quake in 2012, September 2012. So down in South America, Costa Rica, and then these are the seismic sensors in the US. So they all lit up. The vibrations went up, and it lit up the sensors in the US. So that was a 7.6 magnitude earthquake in Costa Rica, September 5th. It arrived and reverberated through the ground beneath the United States. Okay, and this is a visualization showing the Earth moving up and down. Okay, blue is up, red is down. Vertical motion. So it's like you throw a pebble in the pond and it creates effects afar. Okay, in this case the pond is North America. Okay, so there's about 400 seismometers in the array, and they provide like a CAT scan of the Earth, if you like. The seismic waves travel at different speeds. The denser the rock, the faster the speed. There's different types of waves. There's P waves and S waves. Transverse waves, longitudinal waves, and they travel at different speeds. So the Costa Rica quake was 25 miles below the Earth's surface, 87 miles west of San Jose, and then the sensors were lit up in the U.S. So there's a connection, right? We need to look at the whole system. Okay, this is an article which came out in Live Science about a month later or weeks after Sandy, and it again shows the seismic sensors lighting up, and it says Sandy shook U.S. like an earthquake. Okay, this article does not talk about the earthquakes that occurred off Canada.